Hi guys, today I'm going to cover Chapter 7, Section 5, which is all about parallel lines and proportional parts. So by the end of this lesson, you should be able to use proportional parts within triangles and use proportional parts with parallel lines. Off to my left here are the corresponding ALEKS objectives, and then here's some math humor since we're dealing with proportions. Let's talk vocabulary. So a mid-segment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. So every triangle would then have three mid-segments. One is currently shown. So the one that's shown in this picture would be segment DF. I know that because based on these congruence markings here, point D would be the midpoint of segment BA, and point F would be the midpoint of segment BC based on the two sets of tick marks. And so the segment that is connecting those two midpoints is called the mid-segment. I hope this sounds familiar to you, and gold star goes out to anyone who remembers the first time we learned this vocabulary term. What did it apply to? It applied to trapezoids. So we're going to have different properties for the mid-segment of triangles. And here's a few theorems for your notes. The first is the triangle proportionality theorem, which states if a line is parallel to one side of a triangle and intersects the other two sides, it divides the segments or the sides into segments of proportional lengths. So in this case, the line that is parallel to, the line that is parallel to one of the sides and it intersects the other two sides of a triangle is segment BE. And what it does is it cuts the parts of side AC and AD into proportional parts. So meaning, in this case, AB over BC equals AE over ED. So just stay consistent in how you're comparing the things and it should work out. The converse is also true, so it says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then what must be true about that line is it must be parallel to the third side of the triangle. So we're going to practice now applying that triangle proportionality theorem. So it says in triangle RST, segment RT is parallel to segment VU, and SV equals 3, and all these other lengths are given there. We want to find the length of SU. So let's set up our proportion. What I was saying earlier, I kind of briefly touched on it, is as long as you're consistent in how you're comparing the ratio for your proportion, you're gonna be just fine. So some people wonder, does it matter? Do I start with 8 or 3? No, as long as you're consistent on the other side. So I'm gonna start with VS over RV. And you know what? I'm gonna change that to a different color. And then compare it with X over 12. So that's gonna be how I set up my proportion. 3 over 8 equals X over 12. And then now we can use the cross products property to solve this proportion. So we would have 3 times 12, or 36, equals 8 times X, or 8X. And then now let's solve this for X by dividing by 8. Here we go. And I think we're gonna get a decimal here. 4.5. All right, so that means the length of SU equals 4.5. All right, so example 2 is really going to be applying the converse of the triangle proportionality theorem, determining if the lines are parallel. So let's, go ahead and label the information from the given in the picture. So DH is 18, HE is 36, and then DG is a half the length of GF. We could write that in there if we want. So basically, if the triangle proportionality theorem applies here, that's going to mean that, normally these ratios would be equal. 18 over 36 would be equal to the other side. But in this case, they kind of have it a little bit more abstract. So what we need to do is we need to determine, is the relationship in this ratio the same as the relationship in this ratio? If it is, then those are proportional, which would imply that the two segments are parallel. So let's go ahead and compare the ratio 18 over 36. All right, so does this reduce? Yeah, it does. If we divide both by 18, and we get 1/2. So what have we proved here so far? That the length of DH, 18, is half the length of HE, 36. And does that ratio correspond with the other side's ratio? Yeah, because that relationship was also half of the other side, or the other segment. So we have proved yes, GH is parallel to FE. And so I'm going to say yes, GH is parallel to FE by the converse of the triangle proportionality theorem. Okay, I had to think about my spelling for a moment. All right, now let's talk about the triangle mid-segment theorem. So remember I said that mid-segment, that vocabulary of the day, was going to have special properties. So here they are. A mid-segment of a triangle is parallel to one side of the triangle. And by the way, this makes sense because a mid-segment so far would kind of apply with that triangle proportionality theorem. But if we take it a step further, its length is going to be half the length of the side it's parallel to. So in this case, we know segment JK is our mid-segment based on the tick markings here, showing that it's the midpoint of each side. So we know that the length of JK is equal to half the length of the side it's parallel to, FG. Okay, now let's apply that triangle mid-segment theorem. So it tells us that in the figure, both segments DE and segment EF are mid-segments. So here we're asked to find the length of AB. So we need to figure out what mid-segment is going to correspond with AB. Well, the one parallel to it is going to be ED. And so that's the one we're going to look at here. We're not going to use FE yet. All right, so we know from that triangle mid-segment theorem that the length of the mid-segment, in this case that's DE, is equal to half the length of its parallel side. So let's plug in what we know. We know the length of ED or DE, whatever you want to call it, is 5. Now let's solve this for AB simply by dividing by 1/2 or multiplying by 2. Therefore, AB is 10. All right, we're given the same information on this other example, but this time we're asked to find the length of FE. So I'm going to go ahead and mark once again. If FE is what we're asked to find, then the segment it is parallel to, or the side it's parallel to, be segment BC. So let's set up our equation. We have the mid-segment is equal to half the length of the side that it's parallel to. We can substitute 18 for BC. So just half of 18 is 9. Okay, so once again, we're given the same information. This time we're asked to find the measure of angle AFE. So, first of all, I'm going to just show you where that is. Angle AFE is right here. Okay, so remember there's really two parts to the triangle mid-segment theorem. One part is that, yes, it's all about the side length stuff. The other part is that the mid-segment is parallel to the third side. So parallel lines sometimes help us find angle measures. So let me point something out here. If I look at one of my mid-segments, so segment DE, I'm going to extend segment DE here. I know it's parallel to segment AB here. And then I know that segment FE would really act as my transversal. If I have two parallel lines in a transversal, all sorts of angles are congruent, like alternate interior, alternate exterior, corresponding. So in this case, angle AFE is an alternate interior angle with angle FED. Therefore, they are congruent if they're formed by those parallel lines. So long story short, the measure of angle AFE is also 87 degrees. Okay, so today the checks for understanding are at the end of the lesson. Take a moment, read through example 1, and find the length of BY. Alright, and here's some work to show you how to get the correct answer. I do want to point out that my proportion could be set up different than yours, and yours could still be right as long as you are consistent in said setup. Alright, here is the second check for understanding. And here is the work to go over how to find the length of DE using the triangle mid-segment theorem. And going back to the triangle proportionality theorem, here's your last check for understanding. And remember, the converse is really asking you, are these proportional? Because if so, those segments will be parallel. Well, I know that 15 over 25 reduces to 3/5. And I know 18 over 32 reduces to 9/16. So these are not proportional. Therefore, those lines are not parallel.